The Death Star, but not that one. Okay, let's get one thing straight right away. This isn't about that Death Star. You know the one, giant floating spaceball, angry guy in a cape, pew-pew lasers, boom, Alderaan's gone? Yeah, not that one. Sorry, sci-fi fans. This is about the real Death Stars. Actual celestial nightmares. Stars that don't just burn bright in the sky, they go full villain arc and obliterate everything around them. And they're very real, very dangerous, and very cool. Let's talk about how a star dies. So, picture a star. Big, hot, dramatic. For most of its life, it's pretty chill, just fusing hydrogen into helium in its core, pumping out light and warmth, maybe hosting some planets with little alien squirrels on them. But eventually, it starts running out of fuel. And that's when things get spicy. When a star the size of our sun dies, it puffs up into a red giant, like a space balloon on steroids, and then slowly sheds its outer layers in a glowing, colorful farewell. What's left behind is a white dwarf, a tiny, hot, super-dense core about the size of Earth but with the mass of the sun. Not bad, right? A peaceful little cosmic retirement. But Death Stars? Oh, they don't go quietly. If a star is much more massive than the sun, like 8 times bigger or more, its death is the stuff of sci-fi horror films. These stars go out with a supernova, which is basically a stellar-level self-destruction button. The core collapses, gravity says, mine, and the whole thing explodes with more energy than the sun will produce in its entire life. Let that sink in. A single supernova can outshine an entire galaxy for days. And if you're anywhere nearby, well, good luck. The blast sends deadly radiation, gamma rays, shockwaves, and all kinds of space shrapnel flying through the universe. It's not just a light show, it's an extinction-level fireworks display. Fun fact, some scientists think a nearby supernova might have wiped out a bunch of Earth's sea creatures 360 million years ago. Imagine swimming along, minding your own prehistoric fish business, and bam, invisible death wave from the sky. And the scariest part? You wouldn't even see it coming. The light from a supernova travels at, well, light speed. So if one went off close enough to hurt us, say, within 50 light-years, we'd only know when it hit us. Surprise! Now, if the star is really massive, we're talking the heavyweight champions of the cosmos, it doesn't just go supernova. It goes full Death Star. It collapses into a black hole. An actual region of space where gravity is so strong, not even light can escape. It just eats everything. Light, matter, unlucky spaceships, hope, all gone. Black holes are terrifying, mysterious, and surprisingly polite if you keep your distance. But get too close, and you're spaghetti. Literally. Scientists call it spaghettification. Yes, that's a real term. Space is weird. But wait, there's another kind of Death Star, the gamma-ray burst. Gamma-ray bursts, GRBs, are like cosmic sniper shots. When certain massive stars die, they don't just explode, they fire focused jets of gamma radiation out of their poles. These beams are so intense, if one were pointed directly at Earth from thousands of light-years away, it could still fry our atmosphere. Luckily, the universe is big, and gamma-ray bursts are rare. Still, not zero. Sweet dreams. So, why do we care about all this star death drama? Because, ironically, star death is what gave us life. All the heavy elements, gold, iron, carbon, even the calcium in your teeth, were forged in the fiery deaths of stars. Supernovas are like cosmic recycling centers, blasting enriched material into space, where it can form new stars, planets, and eventually weird creatures like us who make YouTube videos about it. Without Death Stars, there'd be no Earth, no oceans, no pizza, no you. Kinda makes you want to send a thank you card to a supernova, huh? In fact, astronomers are keeping a close eye on some potential nearby Death Stars. One famous suspect? Betelgeuse, no, not the movie guy. It's a red supergiant in the Orion constellation, and it's big, bloated, and unstable. Sounds like it's ready to blow. When it does, it'll be the brightest thing in our sky, visible even during the day. But don't worry, it's about 600 light-years away. We'll get the show, but not the punch. Unless, surprise gamma-ray burst. Just kidding. Probably. So next time you look up at the night sky and see all those twinkling stars, remember, some of them are ticking time bombs. Beautiful, glowing, nuclear time bombs. But thanks to them, we exist. And that, my friend, is the ultimate cosmic plot twist. The end. Or should I say, supernova.